into VTI of LVOT. We can find the stroke volume of LVOT by using the formula CSA of LVOT into VTI of LVOT. We can multiply by multiplying these two values. We can find the value of stroke volume. Now the fourth step is the stroke volume of mitral valve is equal to stroke volume of LVOT. We found the stroke volume of LVOT in the before steps, so these both values are equal. We are going to use this fifth step. We will find the velocity time integral of mitral valve area is equal to stroke volume of mitral valve by velocity time integral of mitral valve. So, by following these six steps, we can find the value of mitral valve area. By using the fourth step, we can substitute this as stroke volume of LVOT by velocity time integral of LV.
In mild mitral stenosis, the pressure half time ranges about 70 to 140 mmHg. In moderate mitral stenosis, the pressure half time will ranges about 140 to 220 mmHg. In severe mitral stenosis, the pressure half time will be about greater than 220. The MPG in mild mitral stenosis, mean pressure gradient in mild mitral stenosis will be less than 5. In moderate mitral stenosis, the mean pressure gradient will be range from 5 to 10. In severe mitral stenosis, the mean pressure gradient will be ranges greater than 10. The mitral valve area in mild mitral stenosis will be 1.6 to 2. In moderate mitral stenosis, the mitral valve area will be about 1.0 to 1.5. In severe mitral stenosis, the mitral valve area will be less than 1.
So based on all the steps and the concept we saw before, I will present this simple example from which we can see how the MVA is calculated and on how we can interpret it with the table of column given before this. So let's take an example. In this example, we have all these informations given, which is LVOT diameter is 1.6 cm. The VTI of LVOT, VTI meaning which is the velocity time integral again explained before, that will be 48.59 cm. And the VTI of MV is given as 75.9 cm. So with these given informations, we are going to calculate the stroke volume of LVOT, and with that we are going to now also calculate the MVA. So let's look into. So these are the formulas which we'll be using. It is actually pretty simple. So first we have to find the cross-section area of LVOT, for which the formula is 0.785 into the square of the LVOT diameter, for which we already have the value. And then we have VTI, again for which the value is given. So by calculating these two, we will be able to find the stroke volume of LVOT. So we just have to substitute the cross-section area obtained along with the VTI value which is already given. And after that, once finding the stroke volume of LVOT, we can just equate it to the stroke volume of mitral valve because both values are same, like we have seen it before. So with that obtained, we already have the VTI of MV also given, so we'll be easily able to find the MVA value. Okay, so we'll get into the calculation. So LVOT diameter, as we saw, it was 1.6. So to calculate the cross-section area of LVOT, we have to multiply 0.785 into the whole square of 1.6, and then that answer will be basically 2. So our cross-section area will be 2 cm square. And now with this information, we already have the VTI given as 48.59. So we'll just substitute into the stroke volume formula. So here we'll just do 2 into 48.59, for which the answer will be 4 volume value obtained is basically 97.64, and this value is equal to the stroke volume of mitral valve. Since both these values are equal, both of them are going to be the same. Now we already have the VTI of MV also given, which is 75.9. So we'll just substitute this and the VTI given to find the MVA. So the MVA value we obtained from all these calculations is basically 1.2 centimeters square. And as seen in the tabular column before, 1.2 falls in the moderate range. So in this example was an example of moderate mitral stenosis, and that's it. My friend will further summarize the whole concept.
All the assessment, this is the best, continuity equation is one of the best method to find the mitral valve area. And this is the best example. By using continuity equation, we found out that the patient is suffering from moderate mitral stenosis, and the value is about 1.2 centimeters square. And by this method, we also found out that how to find the stroke volume of LVOT and MV.
So in this class, our student will explain how the continuity equations plays a major important role in echocardiography and for finding out the mitral valve area and stroke volume assessment. For further assessment of cross-sectional area or VTI or inflow of LA, LV, everything can be explained in this equations. So thank you all.